So today, ladies and gentlemen, let's continue with calculus. And we are going to look at straight line motion and in particular, connecting position, velocity, and acceleration. So in previous videos, we have also talked a little about this and particularly derivatives. For example, acceleration is the derivative of velocity and which is the derivative of position. We've also looked at direction, in which a particle moves right when velocity is bigger than zero and left when it is smaller than zero. So let's continue from here. Now, what's speed? Well, the speed is just the absolute value of velocity. That means speed is always positive and increases when velocity and acceleration have the same sign. In other words, even when velocity is negative, so even when the car or any particle moves backwards, the speed can still increase. And finally, for turning point, it is when a direction change requires velocity to change sign and not merely equal to zero. So in calculus, we call a point where v is equal to zero uh, a critical point. But not all critical points are turns, and again, turns requires the change of sign and not merely equaling to zero. Okay, so let's continue with two examples. So let's look at the example. Now, a particle has velocity vt is equal to t squared minus 5t plus 4. And we need to find all times when it is at rest and determine where it moves left. So let's first start with all times when it is at rest. We know that if a particle is at rest, that means the velocity is zero. And so, therefore, we need to let t squared minus 5t plus 4, which is the vt, equal to zero. And with this function, we can factorize a little bit to make it a little bit easier. So we can factorize this into t minus 1 times t minus 4 is equal to 0. Okay, and so when t is 1 and 4, this function, this v function is equal to 0. And therefore, we have successfully found the two times when this particle is at rest. And now let's determine when this particle moves left. So we know that left in the context of this question is the negative direction. And so when this particle is moving left, that means velocity must be negative. So now we just have to determine when our velocity is negative. So there are lots of ways in doing this, but I think the best way is just to draw a axis in which we have 1 and we have 4. And we know that if we have turning points or critical points 1 and 4, then the values of which, whether v of t is positive or negative, must be constant in the intervals. That means if one value of v of t is positive in an interval, this interval must always be positive. And if one value of v of t is negative in this interval, then this interval must always be negative. So because of this, then let's basically just use the v function and check. So between 1 and 4, let's substitute 2 inside this function. Now 2 minus 1 is 1, and 2 minus 4 is negative 2. And so this v of function is negative between 1 and 4. So we label this negative. For t is smaller than 1, let's just substitute 0. It's the easiest way. And if we substitute 0, then it's 0 minus 1 times 0 minus 4. That's 4. So this is positive. And for values where t is bigger than 4, let's just substitute a very big number. So if we substitute a very big number, t minus 1 must be positive and t minus 4 must be positive. So this is also positive. So now we know that the only interval where our particle is moving left is when t is between 1 and 4. Okay, and thus we have successfully found the two values, in particular one value and an interval for our example. And tomorrow we will continue with example 2. So I hope you enjoyed today's video, and I'll see you in the next session.